co-host meeting. Thank you, Christian.
Yep.
Okay, welcome everybody to the Istio community meeting and to 2021 with the Istio community. I'm really happy that you're here. I'm sorry for the disconnect details. And I think there are no community updates or user group updates so far. I'm going to give a brief update. As you may have heard, we are ramping up to um, uh, produce IstioCon in late February. It's going to take place from February 22 to 25. So if you are not yet familiar with the site, you can find it. Let me share it right now. As part of the Istio website here, I'm dropping the link in the chat. It's events.istio.io/istiocon-2021. So we hope to see many of you there to learn how people use Istio in production and learn from leadership of Istio as well as the roadmap for the project. I believe we should be able to announce the program pretty soon, so that's exciting. Please tell everybody you know that is excited about Istio to come to the conference and to share with the community. I'm adding that to the agenda. And I think with that, I am going to pass it on to Christian for the demo.
All right. Thank you, Maria. And definitely thank you for giving an update on the IstioCon. That is the week of February 22nd, I believe.
Yes.
I want to say something about that too. I'm surprised, pleasantly surprised, and it was really good to see the number of submissions that came in for IstioCon. If ever anyone had a doubt about the dominance of Istio as the service mesh that people run in production, I think the submissions that we saw completely put that to rest, right? Large companies, small companies, lots and lots of companies running Istio in production and are successful and excited to share their journey. And we're hoping to have a really good IstioCon program for that. I know some of the organizers are on this call. I think I saw Lynn. It's made it incredibly difficult to try to pick the sessions that are gonna make the cut. And we've even done things like tried to expand significantly, almost double expand the number of slots. So we're doing what we can, but I was blown away, honestly, to see the number of submissions and people excited about Istio and to share their story. So thank you all from the community. These are the folks in the community and other users. Thank you for those submissions and making it difficult for us. It's a good problem to have. So yeah, I'm happy to jump right in here. It's going to be a little bit of a different format. I'm going to say I'm trying something new here. Let me share my screen, and if you can see from my screen, I'm gonna go off a little bit of normalcy and normal script where people show slides and demos. I'll show some demos, but I also really like, I can't, nobody's traveling right now, right? And as part of my work as an architect and working with customers, I really enjoyed traveling and being in front of them and talking about solutions and sketching things on whiteboards and going back and having that collaborative feel. And that's not something that we've been able to do. And so one of the formats that I wanted to try for at least this meetup is trying to go back to that drawing board feel and sketch concepts as they pop into my head down onto paper, or in this case, an iPad, and try to explain and illustrate some of the concepts that come up when people discuss deploying Istio, especially across multiple clusters. We are gonna take a look at a little bit at what I've been working on, and folks here at Sullivan been working on in terms of WebAssembly, and just try to share some of this stuff, and happy to make it interactive, right? Like I said earlier, the best part was being with people and exchanging ideas and trying to draw them out. You know, I would prefer this to be two-way street, so people jump in and ask questions or clarifications or objections and pushback if you see an opportunity for that. So with that, thank you for joining the community meeting, and cross your fingers. Let's hope the iPad and everything cooperates here, and let's get going. Okay, so the first thing I wanted to talk about is Istio, deploying Istio into multiple clusters. That is a use case that we here at Solo work very closely with organizations, some extremely large organizations with hundreds, if not more, clusters, and some of the folks who are just getting started, who might have a single cluster and maybe going into a handful of those Istio clusters, and anything in between. And I'm going to focus on a couple of problems. This discussion could go on for days, but I'm going to focus on a couple of problems specifically around what is the model for how you manage these clusters, how you update the config, what that configuration looks like, some of the complexities that arise in those scenarios. What are some of the models? And then we'll get to we'll switch gears completely and use some of the models that we describe and see how that fits in with deploying and managing extensions to the mesh based on WebAssembly. So WebAssembly is something fairly new that just hit upstream Envoy, and although it has been around in various dimensions and flavors in the Istio proxy for a little bit, especially around customization of metrics and so on. But we can, we're on the cusp of being able to use WebAssembly for a growing set of use cases to extend the capability of the mesh. And in fact, at least here at Solo, we are working with some large customers that are putting WebAssembly into production right now, which a month or two ago, I would have thought that'd be scary, but it's working out really good. So let's see if I can switch into one of these diagrams, and let's start from the beginning, right? So if you go to the istio.io website and look at the documentation, there's a few different flavors for running Istio across multiple clusters. There is the model where everything is on the same network, which if you have and can enjoy a situation like that, then by all means go for it. And what that means is you might run multiple clusters with non-conflicting networks, or rather routable networks between each of the pods, so that a pod in cluster 1 talking to a pod in cluster 2 doesn't have to do anything special, just talk to the IP of that pod or that Kubernetes service, and everything will be routable and everything will be fine. Another model is where the clusters are in separate networks. And in that model, the workloads, they communicate with each other by first going through an ingress gateway, right? So to get to that other network, when they talk to another service, under the covers, they get routed through to the ingress gateway, and then that ingress gateway would pass the traffic through. Now, how does this service here know that when it talks to a service B, that service B actually lives over on a different cluster? Well, Istio has something called the service entry, right? And that's, we put that config piece of config here, and we give it a name of B. Let's say there's a service B, And then when this particular proxy wants to talk to a service B under the covers, you know, using Istio's redirection mechanisms, we're able to force the traffic to go to the ingress gateway that lives in the second cluster. So now this model will happen when you're on different networks and you need to hop to different networks. Now there's another variant to the multi-cluster model, which is sharing or not sharing a control plane. In this case that we see here, we have two different clusters with two different Istio control planes. And the reason that we typically start out with this model is that it allows for various types of failure and isolation. So if this cluster goes down, we're not trying to share a control plane, and that cluster can go down and not affect the other cluster. Okay, so then if we have separate control planes, then we need some way of telling the control plane in cluster 1, we'll call this one cluster 1 and this one cluster 2, that, hey, this is service A. Service A talks to service B, but that service B also lives over here on cluster 2, and the routing that happens between service A and B over here, if this service were to fail, we need some way for the service A pod to know that service B also exists over here and that to go through the ingress gateway. Now, I pointed out earlier that we can do that with service entries. Basically, it's an entry into Istio's registry, of service discovery registry, that says, okay, well, service B is over here also. In 1.8, and although this capability had existed before, but it was officially documented in 1.8, the model that the docs suggest is to connect cluster 1 to cluster 2 to its Kubernetes API, right? So we have the Kubernetes API here, and we also have a the Kubernetes API in cluster 1. And what the doc suggests is create a little secret here on cluster 1 that knows how to authenticate to cluster 2, do the same thing on cluster 2 back to cluster 1, and have them pull the endpoints for all the different services. And so if there are endpoints for service B over on cluster 2 and on cluster 1, then Istio will know about that there's a service B on cluster 2. Right? And in this model, we don't have to create all of the different service entries and so on. Now, one of the challenges or unfortunate side effects of this, as we've seen with some of the folks who've adopted this model, is that the more clusters you have, let's draw a couple more here, the more, and you want to federate the services across these different clusters, the more you have to create these security tokens to talk to the Kubernetes API in the various clusters, right? So every cluster ends up having access to the Kubernetes API of any of the other clusters in that group, right? If we're going to try to discover the services across those clusters. And what we found is that operations folks, platform folks don't like having those secrets spread around to every single cluster, and that every single cluster has access to every single other cluster, at least in terms of its API. And so if we accept that, then we have to say, okay, so what is a different model? How can we, if we're going to solve the problem of service discovery, which we need to do, and we don't want to share these secrets and shuffle them around, because you could have 100 clusters, and and one cluster gets compromised, then all of them potentially could get compromised. It's not a very safe model. One of the options that we've been working with customers around is, let's see if I can go to, let's just go to this diagram, is going back actually to the model of placing the service entries where they should go. And this has a couple of advantages. One, instead of giving every cluster access to every other cluster, you could have something else. Let's call this a config automator or whatever. And this config automation can say, all right, cluster 1 and cluster 2, for the services that need to talk with each other, we will put service entries onto those clusters. And for the ones that don't need to talk, we won't add the services. We won't tell all of the clusters about all of the services, only the ones that need to talk with each other. So we have a little bit more fidelity when it comes to actually paring down the amount of config that gets shared. The second thing is, now instead of all the clusters knowing about all the other ones, what we can have is a model where now only the config automator needs to know about how to access and push config to the various clusters. All right, so now we kind of go back, and we're gonna have a little bit more control over what gets exposed and how it gets exposed, and we're gonna scope down the security surface or potential threat surface down to, let's say, a single service, the config automator or orchestrator piece. Now, even that has its own drawbacks, because there's definitely large organizations where, as I mentioned, they might get into the thousands of clusters. And so looking at it from a scalability standpoint, as well as from a security standpoint, now we have one single component that has access to everything. And so that model this model may or may not work for some folks. And we're working with people where it does work for them, and we have people that doesn't work for them. And for those folks where it doesn't work, instead of one single component knowing about everything and being able to communicate and talk with everything, what we've seen work is the opposite. So instead of pushing these configs, or pushing the demanding security, being able to talk to all these different clusters from a single spot, what we've said is, why don't we push it? Why don't we have the clusters? Oops, wrong pen. Why don't we have the clusters actually connect up to the management plane, or some control config control automation, and say, hey, I'm cluster whatever, why don't you give me the config that I need? And so in this way, we have a much more decentralized and pull-based model, where a single component doesn't have access to everything, and the security boundaries have then been pushed out to an individual cluster, so that if you get access to any one of them, you don't have access to everything. So let me stop and just see, first of all, whether that makes sense to folks, and see whether this is a problem for any of those folks running multiple clusters that they have run into, and maybe how they've dealt with it differently. I'll just open it up for a sec.
Hey, Christian, this is Lynn. I think it's really interesting you are describing this problem. Certainly, there are some challenges I've also heard, that there are concerns to allow even just read access, just to allow the primary cluster to allow access to the remote cluster just on the read access for the API server. So I've also heard similar concerns on that. I think it's interesting how you guys tackle this problem. I'm curious how you secure the connection and the push from individual cluster to the configuration automation
Yeah,
component.
definitely. Yeah. So far, I'm just trying to talk about the problem generally, and then I'll go into a little bit of how we're working with folks to solve this problem. But yeah, just first wanted to kind of lay the groundwork of what's available, what are some of the patterns, what are some of the drawbacks, and talk about it like that. But then yeah, I'll love to go into some of the stuff that we're specifically doing.
Okay, great. But by the way, I really like this presentation style. It's
Yeah,
like
that was gonna be my
so
next question.
real.
Thank you.
It's very cool.
Yeah, thank you. Anyone else have thoughts or questions or acknowledgement that they're following along? This makes sense.
Yeah, Vicente here from Zendesk Technology. It's a task that we have on our backlog to build. We've been calling this internally a remote service reconciler, which was your previous slide. That was the idea we had in mind without digging further. But yeah, I really appreciate you sharing your thoughts, and looks like we're gonna need to revisit and reconsider that architecture that we planned.
Yeah, sure. Happy to share. Yeah. Okay. So that is a great segue to another part of the problem, which I alluded to, but can go into just slightly a little bit more, which is the configuration problem, right? One of the things, I guess, more just as anecdotally, what we see in some of the big outages that make headlines and so on, and even in your own organizations, this may be true as well. Certainly has been in my past, where changes to the system typically consist of more than just application code changes, right? There's the more stuff we push into the infrastructure, the more things we lean on with configuration, config, shuffling around configs, getting the configs right, and so on. Configuration ends up being a gigantic reason why things fail or take outages. And so another part of this problem is, how do you, it's not good enough just to say, like, so for example, in Istio, if I need to configure a service in one cluster, I'm typically touching things like the virtual service, destination rules, sometimes a sidecar resource. And when I'm doing that across lots of different clusters, if they're all heterogeneous clusters, maybe the problem isn't as bad, but still we have to push those configs, identical configs, out to the different clusters. But if they're not, if they're different clusters, if they are heterogeneous clusters, then the configs slightly change, right? And the direction of traffic is sort of implied in the configuration, and somehow that needs to be accounted for. Now, if you take this and spread it out to, let's say, a whole bunch of different clusters, now we have to shuffle these configs, make sure the implicit directionality and all of the other stuff is taken care of. That's, even if you had all of this put into your GitOps pipeline, there's still a lot of moving pieces here. Let me just switch back to this one. This is the one I wanted to be on anyway. There's still a lot of moving pieces here, and a lot of ways that things can go wrong. So what we've been working with folks on is, how can we simplify this a little bit and abstract this away a little bit, so that the model that you use as a user, right, is a little bit more simplified and focused on what it is that you're trying to do with the platform as a whole, whether it's Istio or whatever, right? You're trying to orchestrate a release, or you're trying to introduce, maybe you have a bunch of different clusters running your application workloads, and you have a separate cluster where you introduce canary releases. All right, and in that separate cluster, you want to get some traffic that's flowing in the rest of the system over to this separate cluster, this new canary cluster. All right, what you care about is doing the release, making sure the canary works. You don't care where, that the fact that there's a canary cluster or more canary clusters, or the whole physical topology deployment isn't what concerns you, at least as a developer. Like, I just want to release my service. I want to make sure that it's up. I want to make sure that if things start to fail, they fail gracefully. That in certain cases you take locality into account and so on. But the actual, whether there's virtual services on this cluster that match and service entries and so on, you focus on the part that matters to you. All right, and then that comes back to this concept of the something that can manage that configuration, something that can manage actually configuring clusters the correct way, with the right virtual services, with the right direction that everything needs to be configured in, but simplifying the model that the end user has to worry about. And so I guess without more drawing and stuff, why don't I get into the what we've been working on, or what we've been doing, and how that fits with this problem. And then we'll extend that. We'll take a little bit of a shift, and we'll extend this same problem and apply it to how we manage customizations to the data plane, customizations to the service mesh itself. All right, so let me move this thing out of the way. So what I'm going to show you real quick is so we have a system. Let's see if I can bring this thing back over. The architecture looks like this. All right, we have a few different clusters, and we have some piece that is smart enough about the configuration, and can automate that configuration, and has an API that users can use to influence the different configs that end up getting sent down to these clusters. So if we just look real quick at the demo, we have two different clusters in this case, running on GKE. Cluster 1, Cluster 2. They run some parts of the book info demo from Istio. You can see product page and details and reviews v1 and v2. In the second cluster, we see reviews v1, v2, and v3. So you can kind of think of Cluster 2 maybe as our canary cluster. We're introduce a new version of reviews, and we want to, from the rest of the traffic in the fleet, we might want a percentage of that to come to this canary cluster. And if things fail at that cluster, then whatever, we'll blow it away. So the first thing that we want to take a look at is the app, and make sure that it's working. Full host 9080. Move to product page, cross fingers. All right. So the normal working app that we have running, this happens to be in cluster 1, but the reviews v1 and v2 are in cluster 1 and cluster 2. We refresh, we see it, reviews v1 and v2. That's all normal. But what we want to do is we want to release reviews v3, and we want to do that in a canary fashion. And what we're going to do is we're going to use an API, a little bit more simplified API, but it does take into account the fact that there are multiple clusters. Now you can be very explicit and actually name the clusters, or you can completely leave that out and it'll apply to all of the services across a fleet of clusters. But in this case, we do want to be explicit and say, well, route, in this case, I'm going to choose a large number so we don't have to keep refreshing, but I'm going to route actually 75% of the traffic to any of the traffic coming into the review service to the canary that would be running in cluster 2. And this traffic policy resource, so this is the API that we came up with that it actually, I was about to say it suits most people, but it actually doesn't. There's no one API that suits most people or everyone. And there's some reason behind this. This API is actually customizable. You can change the shape of this API depending on who needs to use it. And I'll talk about that later. But so anyway, we have this traffic policy API that is a little bit more focused on what is the source of the traffic, what is the destination of the traffic, and what is the rule that needs to apply to that traffic. So it's a little bit higher, a little bit more abstract on top of the Istio API, but we can still do traffic shifting and that kind of thing. So let's apply this to our config automation, or we call it management server management plane. And then when we come over here and cross our fingers, we refresh, we should see some traffic go to the red stars, which would be reviews v3. So it is going across from cluster 1 to cluster 2 because of this automation, or because of this configuration. The automation under the covers, so if I take a look at our policies, we see our policy here. We've routed 75% of the traffic to a different cluster. That's all good. But under the covers, if we look at one of the service meshes, we see the correct virtual services, the correct service entries, destination rules, any of the Envoy filters that we need to use here, gateways, and any of those things have automatically been created and put on the right cluster where that particular mesh lives. So if we happen to look at virtual service here, this is an Istio virtual service. We see indeed that the direction of traffic is set correctly. So that's an example. We're using a tool called Glue Mesh, which is an open source project, and specifically targeting this problem and more things, but this problem that we described here. And this can also be used to extend the capabilities of the mesh. So let me show you what I mean by that. So I don't have time, and this is again another thing that we can talk about in detail or have it be its own session. But if you've been watching Istio and Envoy and some of the stuff that's been happening around it with WebAssembly, you would kind of understand that WebAssembly can be used to customize the behavior of the proxy, and you can pick the language that you like for WebAssembly and write the functionality in that language. For there's limitations; it's still emerging, but that is a way to customize the proxy. Now the question is, how do you actually deploy that? I mean, it's nice in a demo to be able to just put it into on the file system and hack the config to load it off the file system and so on. But across multiple nodes, across multiple meshes, how do you manage, or how do you deploy WebAssembly? So I guess the first thing that we want to do is, before we deploy it, is actually build a new WebAssembly module. All right, so I'm gonna use some tooling that we have, but you can use any tooling to build your WebAssembly module. I'm gonna choose assembly script. We'll target Istio 1.8, and that will basically bootstrap for us a project that has all of the right versions for the right excuse me for the SDK that you might want to use for writing your WebAssembly module, and it spits out a sample source code that you can go in and start editing. In this case, we're going to edit the headers on a response, and we'll add a header, hello world. That part, that part is its own topic. But let's try to build it. There's a chance that, do I have Docker running? Let's find out. I actually didn't run through this. It's a bit off the cuff. But what we're going to do here is we're going to build our WebAssembly module as an OCI image, and then from there we can push it into a registry. We'll give that a second, and then once it's pushed into a registry, then then the question comes, all right, how do I deploy this thing? So we built it and we have it. Let's go over here. Let's make sure that, just make sure this is gonna work. And then let's pop into this other, let's delete that, pop into this other demo. And what we're going to see is if we make a call between a pod and the review service, we get a certain behavior, the out of the box behavior, we get the response, that looks good. But what we want to do is install a WebAssembly module to change the behavior, in this case, simple demo of the response headers, right? What we're going to do is we're going to define using some configuration where to apply this change, where this extensibility, where this extension should exist, and what module we want to use, and pull it from a particular repo. And so if we take this declarative model here and say, all right, we're going to apply this to reviews v2 that happens to run on cluster 1, and apply it to our config automation server, management server, then we should, cross our fingers, if we get the deployment itself, we should see a status. All right, it's been deployed. And now if we try to call reviews, might take a couple of tries because we applied it to reviews v2, and it's going to load balance between the two. So let's just try it a couple more times. More times, hopefully it doesn't break. Okay, then we see we do get the extension. We do get this change in behavior through WebAssembly, and so we can do that. We did this. We specified cluster 1, but we could have specified any of the cluster, all of the clusters. And in the way this is working is the WebAssembly module. So it wasn't baked into the image or anything like that. We dynamically loaded it at runtime and actually streamed the module over a secondary XDS channel that was then able to dynamically load into the proxy and obviously here change the behavior of the proxy. And I guess if we look back at the UI, you can see that there's this is something that we added to the particular workloads, and that it's showing that it was installed nicely. All right, so I was hoping to come on and see whether or not the iPad illustrations would work, and share a couple of things that we've been working with our users, our customers here at Solo, and then show you what we're doing around WebAssembly and how that integrates with Istio. But yeah, I won't take any more of your time, and I'll leave it open for questions.
Thank you very much, Christian. I know that we got on a late start, so we may not have time for going into breakout rooms, but maybe we can have a conversation about this demo, and if you have questions or comments, please feel free to speak up, but if that's not an option for you, we can also read the chat.
Yep, sounds good.
Christian, you mentioned heterogeneous clusters. Are you using this model across multiple versions of Istio within one mesh?
So the architecture of the configuration service allows that. We haven't gotten to, we have users who are about to run into that, and we will support it. But so far, everybody's been on the same version of Istio. But this absolutely is intended to be used across any versions of Istio, and potentially even other meshes. But that is the intent, to support that use case.
I ask because I'm interested in feedback. Like do you ever have a scenario where, say, one cluster is having problem with some particular action that you've taken, but others are doing just fine? And if so, what does the feedback loop look like?
Yeah, right now, and so when you say having some problem, are you saying some problem after we've applied some config, or
Sure.
after just because it's having some problem?
After applying config is probably the most interesting scenario.
Right. And so the approach we have for that is to ahead of time you can configure, right? If you say apply this config and it doesn't apply successfully to all of the clusters, then roll it back. Or you can configure it by default to go ahead and apply it, and then if one of them doesn't one of them doesn't work out the way you're expecting, then at least notify the user, and then give enough debugging tools to go help figure out why. So that's kind of where we are right now. So either roll back or fail forward and give supporting tools.
That's great. Thanks.
Mm-hmm. Any other questions? I appreciate you all staying and asking. All right. Well, then, happy to have any folks. Let me see if I can get this back.
A quick one. So I've seen a video about, it was like a 2-3 minute video about Istio 1.9, and there was a very vague mention about a global registry that it will work aligned with Kubernetes multi-cluster support. Are you familiar with those changes that are coming down the line? Will that somehow conflict with the work that you're doing here?
I personally have not. Sounds like it wouldn't conflict. It would make it easier for us.
Right.
But no, I haven't seen that yet.
All right, thanks.
Mm-hmm. Is that anybody on the working groups, Mitch or Lynn or whomever else we have here?
I think that would be the environments working group, and I don't see anyone here at the moment, unless I've missed someone.
Okay.
Yeah, I don't think it's going to be in 1.9. I mean, there are vaguely some discussion around it, but I don't recall being placed into 1.9.
I've got one. This is Derek from Zendesk. A lot of the Istio multi-cluster stuff we've seen kind of anticipates a model where you'll be load balancing requests for the same service across many clusters. Our architecture is such that each cluster is its own shard and they run the same copies of the same services, but we don't want to load balance across. So would you be able to like address remote instances of services deliberately and explicitly without having to, you make a request to service B in cluster 2 that won't go to cluster 3 or 4?
Yeah, no, that's a great question. And so with the model, at least we have within GlueMesh, the services in different clusters will be uniquely identified as being in those clusters. So you can route specifically to those, or if you want to group them, if there's other ways that you want to group them, you can specify a global name and have them grouped to either one cluster or two clusters or whatever. But you can, so if they would be sharded across and they're not heterogeneous, they're just, they're in their own cluster, then you would be able to directly address them.
And
Great.
just to answer your question, in Istio, there is also something called Locality load balancer. So this is something enabled by default, but it's only enabled when you also configure outlier detection inside of your destination rule. So if you have destination rule with outlier detection properly configured, you could just configure, hey, I always prefer local services first. And then if the local services are failing and not meeting my requirements, it would fail over to the remote cluster. So I think that could potentially work for you also.
Okay. Yeah. Locality. Yeah. I think that's a little different because in this case, we want to reach out to specific remote cluster. So local first wouldn't help. Like,
I
one of
see.
the use cases is like moving data from one cluster to another, like a customer gets relocated to a different geography. And we have to move all the data. So we need to, address a specific cluster and push to another different specific cluster, but not with the local involved.
Yeah, that makes
Is that
sense. Yes. So what Christian said, I think makes sense to have that unique ID, the domain for specific cluster.
Yeah, that's awesome. Thank you.
And you can actually use mesh federation to ensure that services cannot impersonate one another across clusters cryptographically, so that every request you're guaranteed to get exactly the cluster you're asking for and nothing else.
And that's with Federation?
That's correct.
Awesome. Thanks.
Except that we don't have an official document on how you do federation today on istio.io.
Cool. All right. Well, I appreciate you all, and reach out if you have questions offline. And yeah, thanks, Maria, for organizing and for having me.
Yeah, thank you for presenting this very original demo. As a reminder, this is going to be available on the Istio YouTube channel in the next few days. I just wanted to let you all know that Jamie has just added the tentative schedule for IstioCon on the Istio calendar, the community calendar. So this is not written in stone yet, so the hours might vary a little bit, but I just wanted you to know that this is where we're going to be updating it, so you're up to date. Next month, we are not going to have a community meetup because we will be hosting IstioCon, but we do hope that all of you can join us for the IstioCon social hour, at least if you're not coming to the conference, which is taking place on Thursday, and it's already on the calendar. So thank you everybody for joining, and we'll see you again next month.
Awesome. Thanks.
Thank you so much.